So on day 2, quantitative data and measures of center. Yesterday we talked about categorical data. So we're going to talk about quantitative data today. And quantitative data is basically, think of the word measurable. So if you can attach a number to a concept like height, weight, age, then it's considered quantitative data. So I'm going to put some examples here. Height or weight. Yesterday I gave an example of eye color as categorical data. So if you can attach a number or it's measurable, quantitative, hence the name quantity inside of the word quantitative. So we're going to start out with a little bit of an experiment based off of some statsmedic.com applets. There's some data on there that was recorded for a geometry class regarding how many hours a week geometry students watch Netflix. So students recorded how many hours per week they approximated that they watched Netflix. And the numbers range from 0 to 30 hours a week. So if you count this set of numbers, I believe that there are 27. So there's 27 students in this sample. I'm just going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I already pulled the information from the website. And the type of data that we have is considered to be quantitative. So we're going to kind of scrunch it in here. Quantitative, because it is countable or measurable. And then what we're going to do is we're going to create a dot plot in this first graph. And we're also going to do a histogram based off of this data. So I took the data and I put it in numerical order. If more than one student watch Netflix for the same number of hours, I listed that. So for example, 4 students watch Netflix for 0 hours a week. And 3 students watch Netflix for 5 hours a week, etc. So when you create a dot plot, that's probably the easiest type of display you can do. You plot every single data point above a horizontal axis. So there are 4 zeros. I'm literally going to go 1, 2, 3, 4. So you stack it like a tower. There's one number 2. So I'm going to go over to the 2 and just do 1 dot. There's one number 3. So I'm going to go over the 3. If you need to, pause the video and create your own number line. So I made increments of 1, but I marked every 5th increment. So I did zeros, I did 2s, 3s. I'm going to do 3 5s. And I want to make sure that my towers kind of match. So I have 3 5s. I have 2 8s. So that would be right here. 1, 2 8s. Kind of got a little bit off on that one. Then I have the most of the number 10s. I have 1, 2, 3, 4, 5, 6 10s. 1, 2, 3, 4, 5, 6 10s. 4 12s. 1, 2, 3, 4. 2 15s. 1, 2. 1 20. And 3 30s. You do not need to extend your dot plot beyond your largest number. But here's a dot plot that essentially summarizes the data in a visual. We can also take this information and put it in a histogram like we did in day 1 of the notes. But we're going to take our information from the list of numbers or list of data instead of from a frequency table. One thing I do want to point out is this bin, these are called bins. And this bin right here is really 0 to 4. And then the next bin is 5 to 9 and so on. So you don't include the far right number on the interval. I'm also going to list up the access like I did before. So I'm going to kind of do a 5 and a 10. And maybe I should make that a little bit higher. Actually, I think I'll be good there. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I probably could have gone a little bit higher, but that's okay. So from here, and actually I think I am, I'm going to make this a little bit more kind of stretched out. Okay, I'm going to erase this too, just so you can see the heights and the bars a little better. And of course, erase everything. So this is 0, but I'm going to go all the way up on this y-axis. I'm going to put 5 here, and I'm going to put 10 here, just so I can see my kind of tallies a little bit easier. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's undo. Of course, it's probably going to erase it again. So we can undo that tick mark and undo this tick mark. And I'm going to undo here and one more. I just want it to be equidistant. 6, 7, 8. There we go. I feel better about that. We do not need to go beyond 10 because the highest number, well, we'll see, because it's going to be a range. So from 0 to 4, I'm going to highlight 0 to 4. I've got 4 and then 5, 6, but I'm not going to include 5. So my first histogram bar, I'm going to go up to 6, and I am going to draw down or draw over and draw down. So if you've got colored pencils or markers, it might be nice to make these bars colorful. And then I'm going to go 5, 6, 7, 8, and 9. And so 5, 6, 7, 8, and 9. So I've got these 3, and I've got these 2. That's going to give me a total of 5. So I'm going to switch up my color here. And we're going to do 5. It's a little bit shorter. Sometimes on histograms, you'll see the number written at the top of it. Like there's 6 here, and there's 5 here. You can do that if you want, but you do not have to. All right, then I'm going to move into my next bin, my next range, which is really the numbers 10 through 14. So 10 through 14 is going to include, I'm going to go back and highlight again. 10 through 14 is going to be all of these and then these, but not including 15. So it looks like I have 6 plus 4 more, or 10 total. That's probably my tallest bin. So I'm going to go up to 10, draw over and down. Notice also how the bins are connected. There's no space in between. And to the best of my drawing ability, I want to make sure that each bin is about the same width. Then 15, I have 2. Let's kind of go back and highlight again. So 15 to 19, I only have 2. So that means I'm going to go kind of right here. I'm going to look over to the left to see where 2 is. And at 20, I only have 1, 20 to 24. There's only 1. And so when I make that bin, I'm just going to go down at 1. I do not have any between 25 and 29. But then at 30, I'm going to kind of conclude this. And at 30, I'm going to have a total of, let's do a highlighter here. 30, I'm going to have 3. So I'm going to go over and make a histogram height of 3. So that will give me right about here. So in this study, in this survey, there were a total of 27 students. So you should make sure you have 27 dots on there and that those numbers all add up to 27 as well. When we calculate the mean and the median, these are called measures of center. So I'm going to kind of underline these 2 words. Those are called measures of center. Measures of center. It kind of tells us how our data is centered. Very obvious phrase. So the mean, you add up all of your data and then you divide by 27. So I'm going to add all values, which means that I'm adding all of these numbers together up here. So if I add all of these 27 numbers and then I divide by 27, I will get an answer of approximately, and I'm going to do an approximately 10.52. So that is the approximate mean. The median is where we're going to put all the numbers in order or values from smallest to largest. And we are going to find the middle value. So I literally, when I do this, I'll count in. So because we have 27, I am going to count in like 12 on each side, because then that would be 24. So now I'll count 13 in on each side. So I'm going to take my highlighter again and do 13 in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then I'm going to count 13 in the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So hopefully you can see there is a middle value of 10. So my median is 10. Sometimes you'll see the mean abbreviated as X bar if it is a sample. So our median is 10 and our mean is 10.52. Those two numbers are really close to each other. So this next one says label the mean and the median on the graphs in number 2. So on the dot plot, I'm going to take orange. My mean would be 10.52. So I'm going to say 10.52 is maybe right about here. 10.52, that is the mean. And then the median is 10. You may have to select like what bin or in what set of dots the mean and the median are in. Which type of display would be easier for you to use if you had to calculate the mean and the median? My response to this is that the dot plot is easier to label the mean and the median because all values are shown. Versus in a histogram, you don't know exactly, like if you were just presented with a histogram, if we just simply take this first bin, we may not be able to see, I know it's numbers of 0, 1, 2, 3, and 4, but we don't know, unless we have the list, that there are 4 zeros. Okay, so let's say we forgot to add one person to the data set and they watch 60 hours per week. So the new mean, if we were to do that, we just add all those values plus 60 more and divide by 28. So the new mean would be 12.29. So we would have to add, again, all these values. So keep adding everything. Plus an additional 60, and then you would then divide by 28. If you were to add 60 onto the end over here, and then have to pick your median, because there are so many 10s, the new median would still just be 10. So that number 60 is sometimes referred to as an outlier because it's way out of the data set. There's a way to calculate if something is an outlier using what's called an upper and lower fence, but we won't be talking about that in this class. So some quick notes just to kind of summarize what we had on that last sheet. I'm going to split this in two. I'm going to write measures of center. And the two measures of center that we'll use, although there are 3 of them, the mean is the average. The median is the middle value. And there's another measure of center or data assignment that we can use, and it's called the mode. And the mode is the most occurring data point. The mode is the most occurring, not the highest, the most occurring. value. So in our data, the mean we said was originally without the 60 was 10.52. The median in this case was 10, and the most occurring is also 10, which is not always the case. Then also a word I brought up was the word outlier. So those are measures of center. An outlier, I'm going to just try to keep this simple, is a value or values that are either much larger or smaller than the rest of the data. So the data are just all the different points that we dealt with. One other thing that comes up, you've seen a couple times, is the word sample. But before I define the word sample, I'm going to define the word population. So when you conduct a study or a survey, population is basically the full group or the whole group. So think of that like the sophomore class. A sample is a small representative group or part of the full group, part of population. So for example, population could be the sophomore class. A sample would be if I went to 6-hour lunch and picked out every fourth sophomore student randomly. So let's check for some understanding. We're going to redo some just like we had on the last slide. So curious math student wonders if the sizes of families are different for students than for teachers. She started with a random sample of 14 students, so N is 14. The number of people in this study are 14, and it says a random sample. So it means that 14 students were selected at random and asked how many siblings are in their family. Here are the results listed in the table. So the word frequency means it occurs that many times. So there are 3 students that have 0 siblings. So I'm going to do 0 plus 0 plus 0. So I got all those. Then there are 4 students with 1 sibling. So I'm going to do 1, 2, 3, 4. There are 3 students with 2 siblings. 1, 2, 3. There are 2 students with 3 siblings. 1, 2. There's 1 student with 4 siblings, and there's 1 student with 5 siblings. And then we need to take all of this and divide by 14. Let me just make sure I have 14. 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14. I'm good. So if I add all of that up and I divide by 14, this is going to be 25 divided by 14, which will give me approximately 1.79 siblings, brothers and sisters. That is the mean or the average for the sample of students. The median number of siblings for the sample of students. So I'm going to count in again. I have 14. So what I'm going to do is count 7 from the left and 7 from the right. 1, 2, 3, 4, 5, 6, 7. And I'm going to go this way. 1, 2, 3, 4, 5, 6, 7. So notice when you have an even data set, the median is right here. So it is the average of the 2 in the middle. So the median in this case, we have to do 1 plus 2 divided by 2, or 1.5. So if you have an even number of data points like 14, you've got to average the 2 numbers in the middle. So 1.5 siblings. I know we can't have 1.5 siblings or 1.79. It's just reporting some statistics and some data. So now we're going to look at the teacher sampling. So in this case, we have 9. You should have 9 total dots. This is displayed in a dot plot. So let's see the mean number of siblings. So I'm going to add, but I'm going to take the information right from the dot plot. I have 2 teachers that have 0 siblings. I have 2 teachers that each have 1 sibling. I have 1 teacher that has 2, so I did these. I have 1 teacher that has 3, 1 teacher that has 4, 1 teacher that has 5, and then 1 teacher that has 8. Remember that the number of teachers surveyed was 9. So this is going to give me a total of 24 divided by 9, which is approximately 2.67 siblings. So teachers have approximately 2.67 siblings in this study. And then the median number, because I'm talking about 9, I'm going to go 4 in. So 1, 2, 3, 4 in. And then 4 in again, 1, 2, 3, 4. So it looks like the median in this case is the number 2. So my median is going to be 2 siblings. And then to conclude all of this, it says the teacher with 8 siblings actually has 16 siblings. Holy cow. So we'd cross off the 8 and we'd put in 16. If we were to correct this in the data set, how would that affect the mean and the median? So what I would do is I would cross off the 8 and put in 16 and then divide by 9. So this would be 24 plus 8 more, because actually if they said 8, I can just add 8 more to that to get 16. Dividing by 9, so my mean would be affected 3.56, almost 1 whole more sibling. So that teacher would definitely be an outlier. But the median, because it's still just, we're replacing a number, 8 with 16, we still would count in, our median would still remain at 2 siblings. All right, so now you're going to be working on the homework, which is day 2 for statistics.